So if you're struggling on number 8 here, you've got a hockey puck and it is sliding to the right. So somehow it had initial velocity. We want to draw the forces on it. So we have the gravity force, which goes down, F of g. The normal force, which is the ice pushing up on it, is a normal force. And those two forces cancel. But because it's sliding to the right, there's going to be a friction force to the left. Okay? And I think you are told in the problem a couple of things. You know the initial velocity of the hockey puck. You know the coefficient of kinetic friction. And you know the mass of the hockey puck. So the first thing you're going to do is question A asks you what is the friction force on a hockey puck. And so just remember the friction force can always be found by taking mu times m times g, and if it's sliding, it's mu sub k. So whatever coefficient of friction you get times the mass times g is going to be the friction force. Just remember that that is acting to the left. Okay? The second thing you're going to try to find is the acceleration. So now we're going to apply Newton's law. Newton said if you add up all the forces on the object, you get the mass times the acceleration of the object. We are not worried about the vertical forces in this case. They cancel. So the only force, the net force, is the force to the right, excuse me, minus the force to the left, which is the friction force. And that equals ma. And you're going to solve for the acceleration. Okay? And of course it should be negative because it's slowing down. The third step asks you how far does the hockey puck travel until it comes to a stop. So here you need to remember that I give you the initial velocity. The final velocity, if it comes to a stop, is actually 0. And so you're going to solve an equation. You know the initial velocity, you know the final velocity, you know the acceleration, and you got to find delta x. So you're going to solve one of our equations from the first unit for delta x. And that's how you solve that problem. Okay? So, give it a try.